Okay, so radicals and rational exponents is lesson 5.1. All right, so we'll go ahead and go through each of these first few examples then together and to get you started for this new chapter then. Okay. All right, I want to recall that when c is greater than or equal to 0, the square root of c is a non-negative solution. So when we're talking about radicals, reminder, we're looking at like a situation of x squared equals c. Reminder, you're going to get plus or minus with those answers. Cube roots, fourth roots, and higher roots are defined in a similar fashion. Here is this chart here then tells us about solutions for x raised to the power of n is equal to c. If n is odd, we have exactly one solution for any c. Right, so there's always going to be at least one solution there. If n is even, then we could have two solutions, one solution or no solutions, depending on the value of c. All right, and for nth roots, so if c is a real number and n is a positive integer, the nth root of c is denoted by either of the symbols. So we could have the index could be n, the nth root of c, or I could write it as c to the power of 1 over n. So looking at rational exponents. So the solution of x to the n is equals c when n is odd, or the non-negative solution when n is even. Okay? So here's a couple of examples of nth roots. Like if we have the cube root of -8, we could say that's the same as -8 to the 1/3 power. And that's equal to -2. If we had the fourth root of 81, which would be 81 to the 1/4 power, that would be equal to 3. Okay? It's not plus or minus 3. It's just 3 because we're not solving an equation, we're just simplifying. Expressions involving nth roots can be simplified or written in a variety of ways by using basic facts of exponents. So for instance, here we've got the nth root of c times d can be the nth root of c times the nth root of d. Right? That's the same thing. We've simplified radicals before. Or I could use it as a rational exponent of 1 over n. And you can see here I've written in red the cube root of y to the 7th. So that could also be written as the cube root of y cubed times y cubed times y. Well, what is just the cube root of y to the 3rd power? What does that equal? Okay, that's just equal to y. So if I was to actually simplify this down here, the y cubes would each give me y. So this would be y squared and then times the cube root of y. Okay, if I was to simplify that completely. So we're going to look at simplifying radicals. So a little review here then. So the square root of 6 times the square root of 8, what do I do there? What do I do to find that answer? Okay. All right, if we're multiplying radicals together, then you multiply what's under the radicals together. So this would be the square root of 48. And then we would simplify that. Well, so what's the largest square that goes into 48? Largest square. 4 goes into 48, right? Okay, 16 does. Okay, so that's the square root of 16 times 3. So that would be 4 times the square root of 3. Reminder that when we're adding or subtracting radicals for letter B, you've got to have like radicals to be able to add or subtract them. So the way it looks right now, I can't do anything. Okay? So I would have to subtract them to be able to, or I would have to simplify the radicals so that I have like radicals before I can actually subtract them. All right, so first we need to take 45 and simplify that, the square root of 45. What do we get if we simplify the square root of 45? Okay, 9 times 5 is 45. So that makes that, okay, 3 square roots of 5. And what about 125? What's the largest square that goes into that? Okay, 25. So this is 25 times 5. So that would be 5 square roots of 5. So we would get negative 2 square roots of 5 there. Let me simplify it. All right, so how many of you know your squares? Can you remember them? Okay, hopefully if you don't, you might want to write them down. Make a list of the squares. 1 squared, 2 squared, 3 squared, and so on, so that you can remember them. You should list them up to 12 squared. Okay? But you should also do cubes and to the 4th power, because we're going to be using them also. Right? So you should have a little table, a list of squares, cubes, and things to the 4th power. Okay? So C, we're working with cube root here. Is there a cube root of 1,000? What's the cube root of 1,000? All right. So the cube root of 1,000 is 10. What's the cube root of x cubed? X. All right. And we worked with y to the 7th power already. So the cube root of y to the 7th, we did that up here. Okay. So we would have, that's y squared, and then we would have the cube root of y left. Now, one of the things you might want to do is put that in parentheses so that you don't get the exponent from the y squared and the index for the cube root mixed up. Right, and go ahead and do letter D. Go ahead and multiply that. All right. Alyssa, what'd you get? So what'd you get? Hmm? Oh, okay. All right.
Would you just times it out?
Yep, just FOIL. So we have, this is the difference of two squares too, right? Okay, so there's no middle term. So we get 36, and then what's the square root of b times square root of b? Square root of b squared, right? Which is just what? Which is just b. Okay, so you should have 36 minus b here for your answer. Because we'll get 36 minus 6 square roots of b plus 6 square roots of b, and then minus square root of b squared. So the last, we get this, and that just equals b. And we can also use a calculator to approximate each expression to the nearest 10 thousandths. How many decimal places is 10 thousandths? All right, yep, 3 decimal places. So go ahead and use your calculator and find the answers to number 2 then. Rational exponents. So basically all rational exponents are is where we're going to take our exponents and we're going to write them as fractions, right, to simplify them. So they come in the form of 1 over n, okay, or which is called the nth roots. And they also can be written as m over n, like 4 to the 3/2 power. So we're going to be looking at the rules of exponents that we've used in the past, and we're going to be using them with rational exponents. Now, one of the things to look at is down here that if we take 4 to the 3/2 power, we can find the answer to that or simplify that in a couple of different ways. We can do 4 to the 3rd power to the 1/2 power, okay, because 3 times 1/2 is 3/2. And that would give us 64 to the 1/2, which is the same as the square root of 64, which is 8. Or we could do, write it as 4 to the 1/2 power to the 3rd, which is square root of 4, then would be 2 to the 3rd, which is 8. And now sometimes which way you do it to find an answer, whether you use the first method or the second one, kind of depends on the problem. In this situation here, which one of them is actually easier to find the answer? Okay, the second one, because we're working with smaller numbers. Anytime I can work with smaller numbers, it makes it easier, of course. So here's the way it works when we're doing rational exponents. That if we have c raised to the power of tk right here, then that's going to be the kth root of c raised to the power of t. So the denominator is the index. That's the number that goes here for the radical. Okay? The denominator goes there. The numerator is the exponent inside. Either it can be inside the radical, like it is here, is c to the power of t, or I could just say the kth root of c, and that whole thing raised to the power of t. And that's another situation where it just kind of depends. One way is easier to find an answer than the other one is. Now they do give us a caution here also. All right? So although negative 8 to the 2/3 is equal to 4, and 4 is a real number, if I enter negative 8 to the 2/3 on some calculators, it may produce either an error message or a complex number. If this occurs, you can get the correct answer by entering one of the equivalent expressions below. So I could do either of these to make sure I get the right answer. So here's a reminder of all the laws of exponents too. Right? When we multiply with the same base, we add the exponents. When we divide with the same base, we subtract them. If I have a power raised to a power here, then we multiply them. So in this case, it would be r times s. Number 4, if I have a product raised to a power, then it's each of those pieces of that product that raised that power. If I have a quotient raised to a power, then each part is raised to the power also. And a reminder, if I have a negative exponent, I can think of it as taking the reciprocal to make the exponent positive, or I can think of it as moving it to the other part of the fraction, because this is over 1. So I could take the reciprocal and change the sign, or I could think of it as just taking c to the negative r, and I move it to the denominator c to the positive r. All right, so we're going to look at simplifying some expressions. All right, so here we got number 3. They want us to write this using positive exponents. So there's actually quite a little bit here we have to work with. So what we're going to do is we're going to pull it all apart. So this means that we have 16 raised to the 5/4 power, u to the 2/5 power raised to the 5/4, and v to the -4th raised to the 5/4. So what we're going to do is we're going to take the rule here that says when I have an I have this exponent on the outside of the parentheses, I'm going to multiply it by the exponents on the inside. I can either think of it like number 3 or number 4. So we're going to rewrite it first of all. We'll say this is 16 to the 5/4 power. And then u, and what am I going to do with the 2/5 and the 5/4? Yep, we multiply them. So that would be u to the 10/20. And v to the power of, what's -4 times 5/4? Is it -20 over -16, or is it -20 over 4? Okay, it's -20 over 4. Okay, so this would be over 4. Okay. So now the u and the v, those are easy to simplify. All right, but 16 to the 5/4 is a little bit more difficult. Okay. So we have a choice here. I can either think of this as 16 to the 5th power to the 1/4, or I can think of this as 16 to the 1/4 to the 5th power. Which one do you think would be easier? Do you know what 16 to the 5th power is? No, I don't know either. Okay. Right. But what's 1/4 power? That's the same as the 4th root of 16, isn't it? Okay. Do we know what the 4th root of 16 is? What number raised to the 4th power is 16? Okay. 2 is, right? 2 to the 4th power is 16. So that means this is 2 to the 5th power, which is what? What is it? 32. So they asked me to write this expression using only positive exponents. So the 16 to the 5/4 is 32. So we have 32. Oh, I'm not going to write there. So we have 32. And u to the 10/20 is 1/2. And then it says using positive exponents. So I have v to the -20/4. So I'm going to put that in the denominator, and it becomes v to the 5th power. Oops. There we go. 32 u to the 1/2, v to the 5th. Okay. So you go ahead and try to do number 4.